general. Let's say it was this. Let's say h of x was some constant to the f of x power. What's the derivative going to be? What's the derivative going to be? If a is a constant, what's it going to be? Let's say, what is it here? ln a times a, yep, times what? Yes, f prime, exactly. It's the chain rule right there, yeah, exactly. Yep, that's the chain rule with that. Yep. And what do you do with that fifth power? Brings to the front, and then what does it become? Turn it into a 4, and then this right here, that's the derivative of what? That's the derivative of the inside right there. So what do you do to get from here to here? You take the derivative. Why? I can almost spell derivative. I can almost write as well. Derivative, because of the chain rule. Exactly. And then can you simplify it a little bit? Yeah, the only simplification here, you see there's a negative sign right there, and then there's also a 2 right there.
So the negative carries over with it, and then the negative sign?
Yeah. You just put it out front. It's all being multiplied together, Nick. Yeah, exactly. Is secant squared. You have to memorize that. You have to memorize that. Just know that. Know that. Okay, so here's another derivative fact that I'm going to give you right now. The derivative of natural log of x is 1 over x. The derivative of the natural log of x is 1 over x. It's pretty cool. It's pretty neat, and it's super powerful. It's super powerful. The way you prove that is this. Everybody, take a look, heads up. You don't have to write this down. You shouldn't be doing anything. This is when you just need to see. I'm never going to ask you to do this out as a required question. It might be like a bonus question. Do you remember this log rule? You might remember this. A to the log base a of x. Does anybody remember what that equals? Does anybody remember what that equals? What did you say? X. It does equal x. As long as you have the same base in both places. You see how it's a to the log base a? So if I made that instead of a, I can write any number there. It's true for any number. It's true for any number. It's true for any number. So what I'm going to do instead is I'm going to write it as e, and this is going to equal, let's say, we'll say y. Everybody with me so far? So this is going to be e to the log base e of x is equal to y. Oh, sorry, is equal to x. Not, it's equal to x. What am I doing? That's the whole point of the rule. It equals x. You with me so far? But what's another way of writing log base e? What do we write it as? We write it as ln. So this is true. E to the ln of x is equal to what? X. Let's take the derivative of both sides. Let's take the derivative of both sides. So if I ask you for the derivative of this, what is the derivative of that? That's going to be ln e times e to the ln x. But then what do you have to multiply this by?
1.
Nope.
The derivative of ln.
Yeah, you have to do the derivative of ln x because of the chain rule. You need to multiply by the derivative of the top. We just did one like that, right? What's the derivative of x on the right-hand side? What's the derivative of x? Not a trick question. It's 1. Okay. Everybody with me so far? What is ln e? What is that equal to?
1.
That's just 1, right? So what do we have on the left here? We have e to the ln x times that. Do we know what the derivative of ln x is? We don't, so I'm going to write it as the derivative of ln x. We don't know what it is equal to 1. What was e to the ln x equal to? What is e to the ln x equal to right here? E to the ln x is equal to, I keep on bouncing this around, I'm sorry. E to the ln x is equal to x. This right here is right here. So what can I replace that with? X. So what do we have here? X times the derivative of ln x is equal to what? 1. We don't know what the derivative of ln x is equal to, right? But for it to be true, what can we divide both sides by? We can divide both sides by x. So the derivative of ln x is equal to what? 1 over x. That's the proof of why it's true. You don't have to do that again, but I wanted you to see it. All you need to remember in this case is the derivative of ln x is 1 over x. You must memorize this. It's super important. The derivative of ln x is going to be 1 over x. So we led off class by doing this. Do we know what the derivative of tangent is? Do you remember what it is? What's the derivative? Secant squared x. You need to remember that. Secant squared x. You have to remember that. 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 Do you remember it? At least right now. It's right there, hopefully. Okay. So we just did this one. We proved that, and we know that for this case, the derivative is what? 1 over x. Excellent. So now what we can do is we can use those two facts in the chain rule. So for example, this one right here. What's the outer function? What's the outer function? What's the overall function? Tangent is the overall function. Tangent is the overall function. So if you wanted to do the derivative of this, what's the derivative of this going to be? Anybody want to guess? Secant squared of what?
2x squared.
2x squared plus 4x plus 1 times what?
4x plus 4.
Yeah, where'd you get the 4x plus 4 from? Yeah, what is this rule? We had to use the chain rule, right? And why did tangent turn into secant squared? Because what's the derivative of tangent? Secant squared. So that's just using the chain rule. What do you have to use on this case? In this case, what rule do you have to use in this case? The product rule. What's the derivative of the first? What's the derivative of the first? So you have secant squared x times sine x, right? Plus the first times the derivative of the second. What's the derivative of sine? You're done. There it is. That is the derivative. There it is. Secant squared sine plus tan cosine. If you were forced to do something more, you might have to do something, but right now, is that the derivative? Yes, that is the derivative. That is the derivative. Okay, see if you can figure out by yourself what the derivative of these two functions are right here. C and D. C and D. See if you can do C and D, and if you finish that, do E. So what's the derivative going to be?
1 over 2x squared times...
It's going to be 1 over 2x squared, but then what do you have to multiply by? The derivative of 2x squared. What is the derivative of 2x squared? 4x. And then can you simplify this?
Yes.
Yeah, so this is, I keep on jumping it down, sorry. Come on. You have 4x over what? 2x squared, so that's going to be 2 over, and then you're done. That would be necessary simplification right there. Does that make sense, everybody, on that one? What is the derivative of ln at x? It's 1 over x. You have to multiply by the derivative of the inside. Oh, so on this one, what's the overall rule you have to use on this one? What's the overall rule? Product rule. The product rule. There's two functions here. Here's the first function, and here's the second function. Here's the first function, and here's the second function. Now tell me what it's going to be here. So I have to use the chain rule how many times? Okay, so the negative 4 is along for the ride. What does the cosine turn into? Nope. Nope. What is the derivative of cosine?
Negative sign.
Negative sign. So it's going to be negative sine of ln of 2x plus 1.
Wait, this is a product rule?
No, it's not. There's no multiplication there at all. That's cosine of the natural log of 2x plus 1. That is cosine of the natural log of 2x plus 1. So it's negative 4. The negative 4 is just along for the ride, everybody. I'm just putting negative 4 on the outside. What's the derivative of cosine?
Negative sign.
Negative sign. So it's negative sign of that, but then what do you have to multiply by? The derivative of the inside. What is the derivative of ln of 2x plus 1? 1 over 2x plus 1 times 2. Exactly. So if you're going to simplify this, what would it become? Negative and negative turns positive, right?
4 sine.
So we make 4 sine of ln of 2x plus 1, right?
Yeah.
Times what? 2 over 2x plus 1. I would leave it like that. That's what that would clearly communicate to me. You have all the pieces right there. That is the cosine of the natural log. There's no product there. There is no product there whatsoever. Outside of the inside times the derivative of the inside. So now you need to do this derivative. We haven't done this derivative yet. What's the derivative of cosine tangent? What's the derivative of cosine tangent? Well, what's the derivative of cosine? So negative sine of tangent, right? But then you need to multiply by the derivative of tangent. What is the derivative of tangent? Secant squared x. So what's the full derivative here? Cosine of cosine tangent, right? Times what? Negative sine of tangent of x times what? Secant squared of x. There it is. Does it get nasty pretty quickly? Yeah, it does. It does. It gets nasty pretty quickly.
What were you going to do to make it more fun?
Wait, hold on. That's going to be my new class ringtone when anybody asks a question. A ringtone is going to go up and it's going to be, what are you going to do to make it more fun? I love the hesitancy. There was 5% genuine curiosity right there and 95% oh God, why am I saying this out loud? What I was going to do, and that's just one I made up off the top of, I just invented them because I wanted to use the chain rule twice with the trig function. What's the other new derivative I gave you today? ln of x, right? So I could just add a natural log on the outside, right?
Just for fun.
Well, here's one. I'll give you one that's not challenging, but it gives you something pretty cool. You ready? You want a fun one?
You said the last one would be fun.
Oh, what? I'm in the checkout at Walmart yesterday where I bought a ton of candy for the math department bowl. There's now candy there, so you can get candy there. And I'm not around during E period, Jen, but the quiz is going to be on Saturday, so we have time to meet tomorrow. And I'm checking out, and I might have bought like 6 2-pound bags of candy to last us through like long weekend in February. And I'm at the checkout, and there's just a woman in front of me. I think she had her kids with her or something. And she looks back, she's like, "Oh Lord, it ain't Halloween." And I'm like, yeah, I found if I just like throw candy at people around me, they get really happy and it makes everybody's lives better. She's like, "You're a teacher." And I was like, yes, ma'am, I am. She's like, "You're a good teacher." I was like, thank you. So random compliments rain line at Walmart because I'm buying 7 million calories worth of like Snickers bars. Okay, here's one. Ready? If I gave you this one, j of x is equal to the natural log of cosine of x. Find me the derivative of that. Find me the derivative of that. Isn't it interesting? So what's the derivative? What's the derivative of ln x, Connor? What's the derivative of just ln x? Oh, and I was